Okay, good day, dear students. Welcome to CRX1003, and this is your business statistics. In this lecture, we're going to discuss continuous probability distribution, or we also call it as a normal distribution. Here we go. Today lectures, we will cover mainly on how to describe the characteristics of the normal probability distribution. And then we're going to discuss about the standard normal probability distribution and how to calculate the probabilities, and as well as approximate the binomial probability distributions using the standard normal probability distribution in order to calculate the probabilities. So these are the main three things we're going to discuss in this lecture. All right. If you can see that the normal distribution, it should look like a diagram, like a bell shapes. Okay. And the center is the mean values. Okay, mean value. Usually given in the mu symbols. Okay, and it's a one peak, right? Usually as a single peak, right? It's we call a peak, and it's also asymmetrical, which means from the left-hand side and the right-hand side is respectively is 50% of the probabilities. And its asymptote is the x-axis, which is the curve, will be extended to the left, and the right, which will not touch the x-axis. And the total under the curve must be equivalent to 1 in terms of probability, okay, or is we call 100%, okay, from both sides, okay, 100%. Okay, so based on that measure of dispersion we discussed, the mean, the distribution of determined by the mean value, okay, and the dispersion or the spread of the distribution is determined by the standard deviation. So we can see that how to distribute the spread of the curve is usually determined by the standard deviation. All right. If you can see that in a characteristic of the normal distribution, okay, so we assume that all the mean, median, and mode are equal. All right, so median, okay, median, and it's equivalent to mode at the center. Okay, it's a mean value, so all equal. And the probability distribution total under the curve, as I said earlier, this must be equivalent to 100%. So you should know that. All right. All right, so this is the curve, all right, as I said earlier. So you can see that it's symmetrical, and at this point, all the mean, median, or mode are equally same. And this is a peak, and this is we call as a tail, all right? Okay, so now let's do some change and similarity, the difference between that standard deviation and the mean. Say, for example, the mean is equally same. Say this point, the mean is all same, okay, the same mean, okay, in the normal distribution curve. So, however, the standard deviations given is different, okay? Okay, so it's clearly show that if the standard deviation increases, the peak will be reduced, okay? See, it's a 3.1 to 3.9. The peak the stiffness is reduced to compared to the standard deviation 3.1. As well, if the standard deviation even greater than that, it will be reduced again towards to down. Okay, but the symmetry is still remain the same since the mean is same for the three category of data. All right. Now, say for example the mean and standard deviations are different. So you can see that mean is given is different. Okay, the three different means, and then the three different standard deviation. Okay, again, you see that the standard deviation for the third one, the third curve is smaller than compared to other two, so the mean looks stiffer, and if the large standard value, the mean is lower compared to the other two. Okay. All right. what happens if that the different means, but there is a same standard deviation? If you can see that every curve is identical, okay. However, the mean are different, okay. So you need to know that. So if the standard deviation is the same, so the peak or the shape will be the same or identical to other, even there is a different mean values. All right. So usually the normal distribution is a normal distribution with mean value with that 0. Okay. So which means, say this is your normal distribution or standard normal distribution. Okay. Your mean value, assume that as a 0, and then your standard deviation, assume that as a 1. Okay. You should understand that. All right. So it's also called as a Z distribution or Z distributions. Okay. And a Z value is a sign, a distance between the selected value, okay, and is given as X. And then the population mean, usually they given is a mu value or mu variables divided by the population standard deviation given the form of variable sigma. Okay, so you can see that the formula here. So in order to see the Z distribution, formula is expressed in this way, which is Z distribution equal to your X, okay, this is your score, okay, Z score minus the mean value, okay, this is the mean value of population, okay, and divided by the standard deviation, okay, standard deviation. So you should remember that. All right, in order to find that the p-value between where the X between A and B, so we call X is distributed normally. Okay, so first of all, what we need to do, we need to draw the normal curve, okay, for the problems in the term of X. So then you need to translate the X value into the Z scores or Z values. So some book, they refer to Z score, okay, or Z values. And you need to use that the standardized normal distribution or normal table or normal distribution table then in order to obtain that the probability or the value. Okay, so in order to calculate the probability for the area we need to find out. Okay. All right. I also will teach you how to use the calculator. All right, in order to calculate the value for the normal distributions. Okay. All right. So you can see that the normal distribution. So usually it will be denoted as, say, PA less than X less than B. So equal to, it can be written as P bracket X greater than A and then minus P X greater than B. So this is a way how we need to write that function. Okay, dear students, let me show you how to use your normal distribution using a calculator. So what all you need to do is, first you just press on, okay, then go to setup button. Okay, once you reach the setup button, you just press 6. Okay, and then choose one variables. And after that, you just press all clear. And then you just choose the option here. Okay, OPTN, that means the option. Press option. And then you just use the down navigator and choose 4 normal distribution. Okay, then you can choose the P or 2 or Q or R. So usually we just stick with one method. So we calculate the normal distributions from the left to right. So we just choose one. Take a look at this example. Say the cumulative standardized normal table in table 3 of the Murdoch statistic table give the cumulative distribution probability greater than desired value of Z. Okay, so for example, the given probability P Z greater than 2. So you need to find out this where it's for. So you can see that the value of which is greater than 2. So greater than 2 means, so this is your Z score, Z distribution. So the 2 is here. So since it's greater than 2, that means you need to take all these regions, okay, these regions. So the shaded regions is a value you can easily calculate using a standard normal distribution table, okay. All right, so also you can use that calculator. All right, so I will show you in the calculator how to find out. So first of all, what you need to do, so you need to in order to calculate this, as we know, P Z greater than 2.00, okay, is also can be written as 1 minus P Z less than 2.00. So which means, so if you choose that the calculator from that right hand side, from the left hand side, okay, towards this direction, okay, so we need to calculate the P value, okay. So you can choose the P. I think you can choose the normal distribution in the calculator. You choose the P. So you will calculate from that value from left to right, okay. So which mean, so if you get the value which is P at Z less than 2, so that means they calculate all over this point, okay. And then you subtract from 1, so you will get the remaining value, which is 0.02275. Okay. All right. All right. So in other method, we can use the standard normal distribution table. Okay. So now we just look for the 2. All right. So 2, you can look at the value at the normal distribution table. So since you need to calculate the 2.00 at this point, okay. So this is what the area we just look for. So this is a mean value. So you can easily calculate by looking at the table. So the Z is 2, all right. So 0.00. So this value will be the probability for the region that you put. Alternatively, you can use the calculator in order to get the values. Take a look at that empirical rule of verifications. Okay, usually this empirical rule of the verification for that normal distribution. All right, so you can see that there's a mean value at the center. All right, so the total probability percentage, okay, with both sides, okay, from mean until one standard mean, okay, to the left and right hand side, because you need to multiply with 2. So just one deviations will be 68%, okay. And then from a standard deviation, from the mean value to the 2 standard deviations, the value will be 95%. And for that 1 standard deviation until 3 standard deviation, so you can take usually 99% and so on. Okay, all right. So this is how you can calculate the empirical studies. How we can manage to get the the percentage values, okay, from the 1 standard deviation, 2 standard deviation, and 3 standard deviation, and so on. Okay, so this is a simple calculation. So as I said earlier, so 1 standard deviations you get about 68%, and then the 2 standard deviations you get about 95%, and 3 standard deviations you get about 99%. Okay. All right, take a look at this example. Say the weekly income of chief foreman in the class industry follow the normal distributions with the mean value of 1,000. So see, the mean value is given, and then the standard deviation is given $100. So this is a sigma value, $100. So the mean value usually we just do not with that mean. So now what is the Z value for the income? And let's call X of the foreman who earn $1,100 per week. Okay, now we're going to calculate that in a while. Okay, so then the next question for a foreman who earns $900 per week. Okay, so there are two questions. So this is question 1 and this is question 2. All right. So based on that, the example 1, so we have the X value, which is $1,100. So what all you need to do, you just substitute the $1,100 to the X. And then mean value, you already know that this is $1,000, and the standard deviation is given as $100. So now we already got that the Z value, which is 1. Now, for the second case, we're going to calculate the when the foreman's earning is about 900. So again, we substitute the X with 900 minus the mean value, which is 1,000, over the standard deviation, which is $100. And we get the minus 1. Additionally, we have another one more examples. All right. So what is that likelihood of selecting a foreman whose weekly income between 1,000 to 1,100? Okay, so same things. So we choose that the given 1,100 minus thousands over standard deviation 100. So you get a 1. And then we just calculate. All right. So P between 0 to 1 equal to P greater than 0 minus P greater than 1. So we get 0.5. You just look the value into calculator minus 0.1587 and you get a 0.3413. Okay, alternatively, you also can do that this way. So P, I can take the largest value, which is less than 1. So less than 1 and then minus P Z less than 0. So you also can get the same answer. All right, so you can see that the normal distribution curve. Okay, so if you just take that the value, this actual value, this is your mean value, okay, which is 0, and then this is your given mean based on the 1,100. So this is 1. Okay. All right, so you can do that this way, so you can get that the shadow regions. So if you take that the mean, the probability value for Z less than 1, so you get all of them, okay, up to all this, and then you subtract the Z less than 0, which is 0.5, okay, this part, okay, then you will get the remaining. Okay, take a look at the second example. Okay, this follow the same questions. Okay, all right. So what is the probability of the selecting shift foreman in the glass industry whose income between 790 and thousands? All right. So you're gonna do the same things. So they look for that between $719 and $1,000. So first of all, you need to check the value. All right, so 790 minus this mean value already given, so 100 over standard deviation 100, so you get a minus 2.10. All right, so this is a calculation. All right, so how are you going to carry out in order to calculate this? All right. Okay, these are another questions. They want to calculate between 840 minus 1,000 divided by 100, so you get a minus 1.6, and 1,200, so you get a the z-score value is 2, so you can do it calculate this way as well. So just write the formulation. So P Z less than 2, okay, and then minus P Z less than minus 1.6. So then you will get the shaded regions. All right, this example 5. So it's given the new value between 1150 and another 1,250. Okay. So again, so when you just substitute those values into the distribution formula, so you get 2.5 and 1.50. All right. So again, you can use that the z-score P Z. This is a high, this highest value, so less than 2.5 minus P Z less than 1.5. Okay, so then you get the answer. So remember, every time when you just find a calculator, you need to come up with the regions which is we look for. So they should be, yeah. All right. Now take a look at this example. Using the Z to find the X for the given probability. Okay. Leighton Tires and Rubber Company wishes to set a minimum mileage guarantee on its new MX100 tires. Tests revealed that the mean mileage is 67,900. So you already know that mean value, which is 67,900. And the standard deviation, so sigma is 2,550 miles, and distribution of the mile follows the normal distribution. Say, Leighton wants to set the minimum guarantee or mileage so that no more than 4%. Okay, they already given is gonna be more than 4% of the tire will be or have to be replaced. So now you need to calculate what the minimum guarantee mileage should Leighton announce. Okay, now. So now what all you need to do, first we need to write the formula. All right, so first we need to write the formula. Okay, so Z equal to X minus mu and our standard deviation is equal to X minus 67,900 over 2050. So this is standard deviation. Okay, now next, since they said this cannot be more than 4%. Okay, so it must be less than 4%. So that means you need to follow within this range. Okay, this region. Okay, 4%. So now you need to look for the remaining of it. Okay, the remaining of it. All right. So you can easily can calculate. Okay. So if you take 50, this this is a 50%. Okay, it's a 50%. You subtract 0.04, and this will be 0.46. So these are unshaded regions. Okay, up to this point. Okay, now how are we going to do that? All right, so you just refer to the table that we have. We just look for that the closest point to the 0.46 is a 0.4599. Okay, so that means you need to take that value, corresponding value of that 0.4599, which is 1.7 and plus 0.05. So which means we add them together. So we get a 1.75. Since it's on the left hand side, okay, so we need to take the negative value. Okay, so means minus 1.75 for the test distribution equal to X minus 67,900 over 2050, and then you just rearrange in order to obtain that X value, which is 64,312, which is mileage. So which means we need minimum requirements. The minimum guarantee mileage should Leighton announce is about 64,312. All right. Now, if you can see that the normal distribution also can be approximate to as a binomial distribution. Okay, so for a certain condition, if you know that the normal distribution give a good approximations of that binomial distributions for the large value of the n. So which means the n value is equal to sample, okay, sample size, okay, sample size. If the n value is larger, so that means it's closer to that the normal distribution curve. So the normal probability distribution is generally good approximation, okay, to the binomial probability distribution when the n value, okay, multiplied by the pi and the n1 minus pi are both greater than 5. All right, using the normal distributions, okay, as a substitute for the binomial distribution for a large value of n seems reasonable because as n increases, the binomial distribution get closer and closer to the normal distribution, as I said earlier. So this is the diagram, it shows clearly. So if it is a small numbers, okay, when n is equal to 1, so it shows that the normal binomial distribution diagrams. So if it is large number of sample, then you can see this is slightly look like a normal distribution curve. So that is what we call, this is suitable for us to use as a binomial distribution. We can easily calculate if a number is larger, we can use that normal distribution, or the other way around. Okay, so continuity correction factors say that the value 0.5 is subtracted or added depending on the problem to a selected value when the binomial probability distribution, okay, is being approximated by the continuous probability distributions. Okay, so you can see that the curve will be look like this. Okay, so the probability and is looked by the normal curve. Okay, now let's see how to apply the correction factor. Okay, first that you need to know that only one of the 4 cases may arise when you're applying the correction factor. First, for the probability at least X occurs when use that area above X, which is minus 0.5. Okay, so the first situation. Second situation, for the probability that more than X occur when use that the area above X plus 0.5. For the probability that X, okay, for the third case, for the probability that X or fewer occur when the area below X minus 0.5. And the last one is for the probability that fewer than X occur when the area below X plus 0.5. So these are the 4 conditions usually we can use that the correction factors. All right, now take a look on this example. Suppose that the management of the Centenary Pizza restaurant found that 70% of its new customers returned for another meal. For a week in which 80 new customers dine at the Centenary's. So what is the probability that 60 or more, or this key point you need to underline, 60 or more will return for the another meal? Okay, take a look at this, the solution. All right, as we know that we know the binomial formula, all right, which is n, the total number of trial, combination x, successful trial. So this pi actually is, usually we can say that is a successful probability, p, probability of success, power of x, okay, the number of successful trial, multiplied by 1 minus pi. Or remember, pi also, as I said earlier, this is a p value, which is probability of success. Okay, so then power n minus x. So now we take when x is equal to 60, so we just substitute those values. So as we know, the 80, okay, so we have 80 new customers. So this is like your total numbers and value, okay. And then we know that the 60% or more, so we just have 60 first, and then the product of success is a 0.7 or 70%. So number of trials, successful trial is a 60. So we just multiply with 1 minus 0.7, power of n minus x, which is equal to 20. So you get the percentage, which is 0.063. All right, if you take the x equal to 61, again, you're gonna do the same things. It's just substitute and get a 0.048. Okay, likewise, we list down everything. Okay, from 60 to 68. So you can add them all up. Okay, all the probability value. So you get that the probability value for the customer, the probability that the 60 or more will return for the another meal will be around 0.197. Okay, so this is how we need to calculate every one of it. Okay, all right. Thank you, student. I hope you understand the contents, and we will see that in next lecture.